All right, let's dive into something it's pretty much everywhere in programming, even if you don't always see it. We're talking about two-dimensional arrays, or as they're often called, matrices. You know, from spreadsheets to video games, matrices are kind of the secret sauce that makes so many things work. So in this explainer, we're going to break down exactly how they work in C.
So think about this for a second. How would you represent a grid of data in your code? I'm talking about something like the seats in a movie theater or all those cells in a spreadsheet. They all have rows and they all have columns. How do you manage a structure like that efficiently? Turns out, programming has a really elegant solution.
The answer is to just think of a grid, like a chessboard. Every single square has a specific row and a specific column. And in the world of programming, we call this a 2D array, or a matrix. It's an incredibly powerful way to handle any data that fits into that kind of grid pattern.
Okay, let's really get to the core of it. What is a 2D array? Honestly, it's just a list of other lists. That's it. Imagine you have a main list representing the rows, and then each item in that list is another list representing the columns. It's a really simple idea, but it's an unbelievably powerful way to organize data that has two dimensions. To put it simply, a 2D array is like a big grid of mailboxes. If you want to find one specific mailbox, you need two pieces of information, right? You need the row number and you need the column number. Those two pieces of info, those are your two indices. So that's the big idea. But how do we actually bring this concept to life in C code? Let's dive into the syntax, because getting this down is the first step to really mastering matrices in your own projects.
Look at this line of code. This is your key to creating a 2D array. Let's break it down real quick. Int just means we're going to store integers. Matrix is just the name we picked. And then the important part. Always remember rows by columns. So 3 gives us 3 rows, and 4 gives us 4 columns. Simple as that. So let's do some super quick math. How many total storage spots do we have in our matrix? It's just as simple as multiplying the rows by the columns. 3 times 4 gives us, 12 total elements that we can store.
Now for the really crucial part. How do you get to one specific element? We use that same two-index system. But, and this is a huge thing to remember in programming, we always start counting from 0. So matrix 1 is actually pointing to the second row, and 2 points to the third element in that row. It's just like finding a specific coordinate on a map. Now this slide shows something fascinating about how computers actually think about 2D arrays. While we see a nice, neat grid, the computer's memory just sees one single, continuous line of data. It lays out the first row, then immediately after it the second row, and so on. This is called row major order, and it's actually really important for performance when you start working with huge data sets. But for us humans, trying to think in one long, straight line can be a total headache. It'd be like reading a book printed on a single giant scroll. That's why we use this logical grid view you see here. The C language is basically our translator, taking our easy-to-read grid and turning it into the computer's linear memory layout. It makes our lives as programmers so much easier. Okay, so we've got our data all organized in this beautiful grid, but how do we actually interact with it? How do we read every element or change every element? The answer lies in one of the most powerful tools a programmer has. The magic key is the nested loop. Basically, you put one loop inside of another one. The outer loop takes care of moving down the rows one by one. And for each of those rows, the inner loop kicks in and moves across all of the columns. It's a super systematic way to make sure you visit every single cell in the grid. All right, theory is great, but let's put this knowledge to the test. Let's look at some really common matrix operations. This is where you'll start to see the real power of organizing your data in a grid and how it can be used to solve actual problems. Let's start with addition. First thing, there's one crucial rule. The matrices have to be the exact same size. If they are, it's incredibly simple. You just add the elements that are in the same spot. So let's do it. Top left of A plus the top left of B, that's 1 plus 5, which is 6. And you just do that for every single element to build your new result matrix. Next up is the transpose. Now, that might sound a little complex, but honestly, it's as simple as flipping the whole thing over. You're basically just swapping the rows and columns. What was a row becomes a column. So check this out. We've got a matrix here with 2 rows and 3 columns. That first row is 1, 2, 3. Now, before I show you the answer, take a guess.
what do you think its transpose is going to look like? Just think about turning those rows into columns.
And there it is. The first row of our original matrix, 1, 2, 3, is now the first column of the new one. And the second row, 4, 5, 6, has become the second column. See how our 2 by 3 matrix totally transformed into a 3 by 2 matrix?
So why should you care about any of this? I mean, rows, columns, transposing. Who cares? Well, you do, because matrices are the unsung heroes of our digital world. They're hiding in plain sight in almost all the technology we use every single day. Literally, every time you look at a digital picture, you are looking at a massive matrix at work, where each pixel's color is stored in a cell. When you play your favorite video game, the map you're running around on is just a huge 2D array. And of course, from financial spreadsheets to crazy scientific simulations, matrices are the absolute bedrock of organized data.
Okay, let's wrap this up with a quick summary of the most important takeaways from all of this. Just remember these key points. Matrices are your go-to tool for any grid-like data. You declare them by defining their rows and their columns. You access any element with a simple row and column index. And you unleash their true power with nested loops to process every single bit of data with ease. So we figured out that matrices are really the foundation of organized data. The real question is, how are you going to use this powerful tool? Whether you're building a game, analyzing some data, or creating something totally new, think about how the elegant structure of rows and columns can bring your next project to life. Thanks for watching and happy coding!